Yo, how's it going, everyone? This is another day, another coding run. So we do have these sample data, which we are going to play with. These are not the real data that we got from real sources. These are just the bogus data that we just created on the fly. Let's go ahead and play with it. So first of all, we are going to import pandas. It's PD. We don't need NumPy. And we're not going to be needing matplotlib because we're just going to use a plot that pandas provide. Let's go ahead. The first thing that we'll the first run is going to be with the flight record. So let's go ahead and create it as a data frame, PD as read CSV content. So yeah, it's kind of I'm not used to with typing and talking at the same time. Eventually, I hope it will get better. But if I am making some blunders, I hope you guys would forgive me. Okay, so we loaded the data. Let's see. The first thing that I would like to see is an A. That's right. Let's see. So there is 8, 9, and A. DF that is. Let's see it as a percentile or percentage. Let's go ahead and do mean in 100. So 8-9% is totally fine. So let's try to understand what the data type is. So these are floats. These are integers and these are objects, right? So let's go ahead and change df indeed. So it calls to df d. Change. Trying to change it to dt state. So when we're starting off, we should absolutely use these autocomplete functionality because we don't want to spend time to just read the documentation. Eventually, we do have that's a best practice, but what we're trying to achieve here is we are trying to achieve the quantity, right? So once we have done 10, 15, 20 iteration, we're going to be used to this syntax. And let's go ahead and see info df date. The idea here is so okay. What we are going to be doing is the describe columns. So now let's try to find a correlation. Ticket price. rather than finding a correlation like this. Let's go ahead and check the shape. Let's pick up. Yeah. So just drop the charger. Let me put the charger back. There we go. Yeah, what it do? So let's do this right. Let's pick up the duration and take a price. Head. Let's see. Does it make sense? What about? Let's see what's wrong with it, right? Okay. So this is the best part about using a Google Colab. Eventually, there's going to be a time where we do have to start paying for it. So what if we get better at the syntax and being really used to it, pandas and some of these libraries before they started charging for it, right? Eventually, if we are doing it full time, I guess it is worth it to get Collab Pro, but it seems like there are some nuns. Also, let's go ahead and see. I'm gonna find that there's any some. So df dot size or save, right? Um, Count the rows. So there are 100 rows, and if we eliminate some of these, it is not going to affect our data. How are we going to make sure that it is not going to affect our data, right? So sum instead of sum, let's go ahead and pick it up again. Let's put this thing out. Isn't it? I mean, still at 9%. So what we are going to be doing is duration and ticket price. Let's just drop it, right? Duration. Let's check a price. Let's see. 84, which means we've dropped some of these out at a certain point. There was other syntax. Now I remember. Instead of using the subset, we could have used something else in the drop columns. So I think with columns too, you could pretty much do duration and ticket. Price and place, cost to true. So we would want to understand what is the difference between this guy and oops, this guy right here. Oh shit. How silly mistake have we done, right? That's the one mistake that we've done. I think we have accidentally removed the columns, which means we gotta load in the data again. So you gotta be careful while you're hitting drop, right? So df equals to read pd dot get csv. Read csv df dot columns. So what are we going to do, right? Let's remove df.info. So first we're gonna change the date again. Date equals to df. P date time. If you would want to give the autocomplete code, what is the ideal here? Scenario is write something here, right? Find all and ands and all columns. Okay, df dot is in a sum. So we're gonna remove these guys. We're going to remove the rows. Price. Oops. Design it. Or row kind of. With we're gonna do is for this time copy as a calls df.copy. So we copied this is here we have created a new data frame that is just a copy of the original data frame, right? So now we can do whatever we feel like with the copy. So what does this guy do? The dot copy. What's that name? Some. So yeah, it looks like it has been removed. df.columns. df.save. So now it looks like we do have all the clean. This was a mistake. Silly mistake. It's not the variable that we were supposed to clean or do some task with.
Hey.
So now what we're going to be doing is df. Let's find what the data type of the data is. The describe. Okay, so df d dot what about this as an AO? So this is the STD. Standard deviation. So let's go ahead and df. Oops. Copy that column. So you might have realized that I meant to use df copy because that's the subset that we rinsed right here. What we're gonna do is this is the variable that we're supposed to use. This is the data set that we're supposed to use. Now let's start playing with the data. I'm not going to drop any columns, man. Okay, let's go ahead and try to see what airlines are there. I'm going to do the uni with value counts. Let's see. Okay. Value counts dot plot. I'm going to be plotting. It's not airlines, it's just airline. Kind calls to bar. So one thing that we're going to be doing is we are going to start plotting everything so that when we it is going to be more intuitive, right? When we see these graphical representation, just rather than just seeing data, it is going to be more intuitive. Um, so now what we're going to be doing is we are going to take two. Let's take the airlines ticket price. Just airlines. Head plot kind equals to bar. X-axis is going to be airline. Y-axis is going to be ticket price. So we still do have, in some of these table, we don't have the ticket price, right? Um, so let's go ahead and see DF ticket price, that is NA sum. There are 9 of them. So what we are going to be doing is ticket DF drop NA subset. Okay. So DF, we were supposed to use DF copy, but you used the other one. So now what we're going to be doing is we're going to be using this guy. There's going to be another one. It's going to be date. We're going to be using the date, another copy, and here we are just going to have head, right? Um, so we are going to be plotting it. Kind equals to bar. X is still going to be it's going to be let's going to put it as date, and Y is going to be airline ticket price. What about the putting it as ticket price? And this is going to be as date ticket price. Oh, there we go. This is how it makes sense though. So what we can actually do is we're just going to put it as x-axis as a date, and this is purely going to be little place. You do have to apply these guys. Oops. Let's see. Okay, let's copy these guys and hash Gemini wireless code. Not removing the from the date. Yeah, what we could actually do is we could pretty much matted date. Head. Looks alright for now. So let's go ahead and copy the same code that we have. Let's try to plot it down. So instead of D, what we could do is, let's remove this airlines. Ticket price and formatted date. Here we don't need it. We're going to put the formatted date. Forget the double quote. There we go. Now let's try to see columns. So what we are going to do now, let's check the destination. Destination and duration. So let's remove and then not a non duration drop and a totally forgot, right? Been getting distracted. And here we don't have an A. There's 88 rows. Let's plot some of it. Let's just use only plot. Is there a way to even plot these guys? Destination. So what is being plot? What's the duration, right? How long does it take? Um, size 10 and 6. Are these the only address that we have? So I think so, right? Let's go ahead and destination accounts will plot kind calls to pi fixed size 10.6. That's amazing. So instead of pi here, it would make sense to have a bar. So it's the time of repetition that has occurred. That's 25 times. Okay, what else are we going to be doing? So we're not going to put pretty much everything. So let's just put the head to the bar. The x-axis, what we are going to have is going to be destination. Okay. Phoenix takes 10 hours. New York takes. Let's have the fixed size equals to 10, 6. So it's pretty nearby to go to New York. In some instance, as these data are being randomly generated, you can tell because if you see right, the destination duration is pretty high over here for New York, but for here it's pretty low. But it's just the sake for a learning pandas in data analysis. Let's just keep on moving. Let's try to see what are some of the interesting columns we have. It's pretty much most of the time it's hard for me to remember the name of the columns. So what I would do is dataframe.columns to see what columns we do have. And let's try to see now the formatted date, what are some of those dates where we are flying the most, where it could be us, or it could be the airlines, or it could just be a flight. Formatted data. The count values. Now the data is just in T, right? What about the value counts? Okay, let's try to plot it. Kind of equals to bar. There's only one data point, right? So it is head. So are these, well, let's just do that. So all of these dates are unique dates. That is totally fine. So what we're going to see from this point is, let's just have date, airlines, ticket price. So let's just see these guys for now, and eventually we are going to add the passenger count, because we might want to see if there is any correlation between date, right? Let's just do head, airline, formatted date. Okay, so this is going to be the price, right? Now, what happens if we do this? There's going to be 84 rows. Sort by sort values. You would want to see price. Display all 84 rows. PD dot set option. Display set options. Display max dot rows. PD dot set option. Display max rows. None. So when we're starting off, right, it does not have to be super sophisticated mathematics or statistic or probability. We can just use super simple math to make a correlation between various data points. Oops. We're sorting it by ticket price. So this data is going to be displayed in ascending order. That's the default setting. Formatted date. FORMATTED formatted date is, we're not used to it using df copyright. So here we can see all of the cheapest ticket here is JetBlue. Now let's also add the destination piece. There we go. Let's just move the destination column to the front. So it looks like the ticket to Los Angeles was pretty cheap, pretty reasonable. At some point, we're going to either scrape data or just pull the real-time data from some of these sources, and it is going to be really interesting to play with this data and try to sort the price and try to make a correlation, say, between the destination, the airlines, and ticket price, right? So the first chain cheapest one, let's just copy these codes. And what we are going to be doing here is head. This is going to be 10. And we are going to plot it down. Here is going to be kind, this is going to be var. X is, axis is going to be destination, and y axis is going to be ticket price. Ticket price. Los Angeles, Houston, Chicago, New York. Okay, it makes sense. So okay, now let's try to add the other column or the other data point that is going to be passenger count. Let's try to see if there is any correlation between having less passenger and having the price goes up, and having more passenger in a flight, and if the price goes down. Let's see. So, oops, I'm not used to using these data points, right? Copy. Now what we're going to grab formatted date. We're going to get the airlines destination pass count ticket price. Price sort. Okay. Let's see. Yep, it looks like the price was going a little bit up, but it does not make sense over here. But what we can do is, can we use correlation table or metrics? Passenger ticket price, price, ticket price. These are capital letters. So what we're trying to do here is we are trying to find a correlation between two columns. The first one is going to be a ticket price, and the second was going. Oops, both of them are ticket price. Here it is going to be PASS, passenger count, right? I still want that, right? Let's click on explain error. Gemini. As my best one right now is Gemini. Ignore string. So what we can do is covered, numeric only. This is another hack that we have found. Oops. What is going on? Let's see. It's the moment of truth. Create a heat map for a correlation matrix. Map. Correlation. Color. So there's a correlation between duration, ticket. So what if we would want to add code? Yeah. It can be hard going to ask Gemini what this result means, right? The correlation metrics shows the correlation between different columns. Okay, so explain all correlation. Explain correlation of all tables, all columns, please. A very weak correlation, close to zero, right? Duration versus ticket price. Says ticket price. It says that longer flights tend to have slight lower price, but the relationship is not very strong. There is a weak negative correlation between duration. Kitokue. The correlation in a dataset are generally weak, indicating that no single factor strongly predicts another. This could be due to a various other influences on flight. So what it means, a price and passenger number are simply the nature of your data you have. So what it means is we can use a correlation as a means of prediction. As we're just starting off, right? We do not have any models that we can use. to do any type of prediction. So for the prediction for when you're just starting off, you can just use the correlation. Okay, I'll see you guys in another video.